Alright, so I left you on a cliffhanger last lecture. We're gonna work on the X method. Okay. So the X method here, oops. Get my PowerPoint back working. Alright. The X method here is where we put A times C up top and B at the bottom. Okay. Now, remember, this is your A, this is your B, this is your C. A is always in front of the x squared, B is always in front of the x, and C is your constant at the end. Now, if I look at A times C, I'm looking at 6 times negative 5. Okay. That's going to give me negative 30. Okay. And then if I look at B, B is negative 7. All right. Now, what I need are two numbers that multiply to give me negative 30 and add to give me negative 7. So multiply to negative 30, but add to negative 7. All right, so we think about the factors of 30. You're thinking, okay, 30, you've got 30 and 1, you've got 15 and 2, those don't work. You've got 6 and 7, or 6 and 5. That's not going to give you a 7. But how about a 3 and a 10? Okay. So if I do negative 10 and positive 3, okay, negative 10 and positive 3, that should work. That should work. Now, the only other thing I have to do is once I figure out what factors I can multiply to give me negative 30 and add to give me negative 7, I have to put those factors over the A. Okay, the A in this case is the 6. Okay, so, and remember, just if you're trying to do this in another problem, you're basically putting those numbers over A. Oops. All right, turn it. Didn't want to let me write. Golly, pen's going wild. But yeah, you're putting each of those factors over A. Okay, so let me get my pen back in the right color here. Then you want to simplify them as much as possible. So this one should simplify down to negative 5 and 3. This one should simplify down to 1/2. Now, here's the key part. Okay, let's start over here. The 3 and the negative 5. The 3 is the number that goes in front of the x, and then you add the negative 5. So I get 3x minus 5. And over here, the 2 is the number that goes in front of the x, and then I add the 1. So my two factors are 3x minus 5 and 2x plus 1. So FOILed out, it is 3x minus 5 times 2x plus 1. And that's how you can use the X method to solve. We might get to use it here a little bit more in a bit, but I highly recommend if you struggle with factoring to watch a couple extra YouTube videos on the X method. Some people are a little bit better explaining it than me. So if you didn't quite get it from me, you can check it out with some other videos, some really great videos to check out on YouTube with the X method. But I highly recommend the X method. Works very, very nicely. All right, now let's look at the perfect square trinomials here. So we're kind of working these backwards. We already looked at these when we FOILed them out, so we know the response of them. Now, if I take this example, it says factor 169 times x squared plus 104x plus 16. Now, when you're using the perfect square trinomials, or you want something that looks like a perfect square trinomial, look at the first and the last numbers. Okay, 169 and 16. Well, 16 is easily 4 squared. 169, hopefully you can recognize that as 13 squared. That should key you in that this might be a perfect square trinomial. Okay, if it is, then you can go back and you can use these formulas here. This one lays out as a positive, so it would be the first formula, to know that it's the first number squared, the second number squared, and then 2 times the two numbers combined. Okay, essentially that's how we break it down here. The first number squared, so 13x squared. The last number squared, 4 squared. Okay, and then 2 times whatever these middle ones are, the 13x and the 4. Okay, now that should tell us, because this does 2 times 13 times 4 does equal, you want to double back and check that this does equal 104, because sometimes they'll be sneaky and it won't work. But if that does equal the 104, it's a perfect square trinomial. You should just be able to back it out into 13x plus 4 all squared. Okay. You can try this one. Oh, look at this one. Okay, that's 16. I know that's a 4 squared. That 9, I know that's a 3 squared. This might be a perfect square trinomial. So I can look at the middle here, and I can look at 2 times 4 times 3, 2 times 4 times 3, that is 24. It's a perfect square trinomial. So I should be able to just say 4x, let's see, plus 3y squared. That should be my answer, working back and factoring it. All right, now let's look at this one. Here I have x squared minus y squared equals x plus y times x minus y. Okay. If I wind up in a case where I see that the first one's kind of a perfect square, okay, here 25 is 5 squared, 4 is 2 squared, and they're subtracted, it's probably going to lead me to believe that it's probably 5k plus 2m. Got ahead of myself. That happens sometimes. Don't do that. And then 5k minus 2m. And that is your factorization. Okay. How about this one, though? How about this one? Well, 16 is 4 squared. Technically, 1 is 1 squared. So maybe this one breaks up into 4x squared because it was a fourth, and I'll kind of half that one there. Then plus 1, and then a 4x squared minus 1. But wait, I think this can be further broken down. This one can't because it's added, so we're going to leave it alone. But I think this next one here, I think this 4 could be a 2 squared. This 1 can still be a square, so this could even break down into a 2x plus 1 times a 2x minus 1. And it does. Okay. That's your difference of squares. And that completes the second part of the lecture. If y'all have any questions, don't hesitate to reach out. Other than that, I will see y'all on the next lecture.